So now, then last class we have just gone through that basics of the multi-stage amplifier. That is bandwidth calculations and gain calculations, and we solved some problems also, some numericals on the multi-stage amplifiers. Now we are going with the analysis of multi-stage amplifier. There are actually the three analysis parts are there. One is cascade, cascode, and Darlington pair amplifier. Okay, three analyses are pending. And so in this class, I'm going to cover this what analysis of multi-stage amplifiers. Okay, so in this, as the first, I'm going to take it as a cascade, cascode. So cascade amplifier. Cascade is nothing but two same types of amplifiers are connected back to back. So two same, it may be what we call CE, CB, CC. Okay, that is a cascaded. So same type of amplifiers are connected. And cascode is nothing but the two different types of the amplifiers, CBCC, like that. Okay, or CECC. Okay, so if you connected two different stages are connected, then we call it as a cascode amplifiers. If the two same type of amplifiers connected, then we'll call it as cascade amplifiers, right? So now let us start with the cascade amplifiers here. Cascade amplifiers. Okay, so in this cascade amplifier, so the same time here we are going to use two-stage RC coupled amplifier. Two-stage RC coupled amplifier, that is E with CC, CE with CE. Two CE amplifiers we are connecting, CE with CE, two-stage RC coupled amplifier. So now let us draw the circuit of the two-stage RC coupled amplifier. Okay, so this is if you know the H parameter analysis of CE amplifier, this analysis will be very easy. And just only thing is you must know that what is the, how to do that the analysis, H parameter analysis for CE amplifier. Okay, so now see, this is the two-stage RC coupled amplifier. Is my screen visible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so this is a two-stage RC coupled amplifier. Here we are going to do that again H parameter analysis, but so already in the second module, so we have done the H parameter analysis for the CE amplifier, that is single stage. Now we are going to do for the multi-stage amplifier, same analysis of H parameters now for the multi-stage amplifiers. Okay, now look at this one. Look at this. So this is the first stage amplifier. So this is the first stage till to this point. Okay, so this is what first stage here. So now what I'm doing, I'm applying output of the first stage. So this is output of the first stage. Okay, so let us say Vs is input, and here it is let input is, let us assume that Vi, this is input is Vi, and this is so input is the first page input, no, so VB1. Okay, so input base voltage, and output of the first stage is VC1, and here input is VB2, and here it is VC2. Okay, so VB1 is the input of the first stage, VC1 is the output of the first stage, VB2 is the input of the second stage, VC2 is the output of the second stage. Okay, so these are the stages now. So now see, output of the first stage is VC1, output of the first stage is VC1. I'm applying to the input of the second stage directly. So through the some RC component. So this is the capacitor and this is the resistor. And through some resistor and capacitor, I'm applying the output of the first stage to the second stage, input of the second stage. Hence, it is named as RC coupled. RC coupled. The coupling is done between through resistor and capacitor. So hence, it is named as two-stage RC coupled amplifier. RC, why it is named as RC coupled? And the first stage is coupled with the second stage using the resistor and capacitor. So hence it named as RC coupled amplifier. Okay, so this is the first this circuit of two stages, and the coming to the operation. So we know that R1, R2 resistors are used to voltage divider bias network and apply the constant voltage to the base. Okay, whatever we discussed about the single stage amplifier, same operation, no change. Only thing is, so that is a single stage, and here we are using we are connecting to the multi-stage amplifiers. Okay, so that is only the difference. And now this is the two-stage RC coupled amplifier. So let me write it here. So that is uh, VB1 is input of first stage, input of first stage. VC1 is output of first stage. VB2 is input of second stage here. Okay, VC2 is the output of second stage. So right, so VB1 is input of the first stage, VC1 output of the first stage, VB2 input of the second stage, VC2 output of the second stage. Okay, now if you see the overall gain will become, the overall gain will become what? So now let us write it as, now let us write overall voltage gain means what? Overall gain. So here also we are going to do that analysis of this overall voltage gain. Okay, overall voltage gain AV equal to AV equal to. So what is the overall? Overall means multi-stage. Output of the second stage is nothing but output of the final. Okay, that I already told. The output of the last stage becomes the output of the multi-stage amplifier. So now output is nothing but VC2 divided by VB1. Input is VB. I'm not considering RS. Okay, if you consider RS, input will be VS. Okay, just look at let us calculate till to this point here, till to this point. So VC2 by VB1. This I can write VC2 by VB2 into VB2 by VC1, VB1. I can write like this. But because VB2, VB2 cancel, and I will get VC2 by VB1. That is equal to VC2 divided by VB2 into VB1 Is my screen visible to all of you?
Yes, sir.
Varun, respond.
Sir.
Yes, sir. It's visible.
Yes, sir. Your screen is visible. Sir, your screen is visible.
Is my screen visible?
Yes, sir.
Am I audible?
Yes, sir, you're audible.
Please post in a message in the chat box. So I'm not getting your voice. What about the audio?
Yes, sir.
Am I audible?
Yes, sir, you're audible.
Okay,
You
you're
are
not raising your voice. Fine. So, but so you are audible, right? Varun, am I audible?
Yes, sir, you're audible.
Please post in the chat box. Okay, fine. Okay. Fine. Okay, so this is in a, I think so. Your voice I'm not able to receive, but okay, whatever it may be. So anyway, you are audible to my voice. That's clear. At any point of time, if you're not able to listen to my voice, please ping a message in the chat box. Okay, I will go with this. So overall voltage gain, so AV equal to AV1 into AV2 into AV1. So that we are going to calculate what is AV2 and what is AV1. Okay, so this is the overall voltage gain. Now let us calculate the overall current gain. Overall current gain. Overall current gain here. AI equal to A equal to we know that actually so IL by IB1, that is equal to IL is nothing but minus IC2. Why? Because if you see the circuit, so this is IL, okay, but so IL is opposite to the IC2 minus IC2 by IB1. So this is equal to minus IC2 by IB1 into IC2 by which section? So క్లాస్ అవుతుంది నువ్వు రికార్డ్కి ఎట్లా వచ్చినావు? వాట్ ఇస్ ద రోల్ నెంబర్? క్లాస్ జరగట్లేదు ఇప్పుడు మరి నువ్వు కరెక్షన్ కోసం మీరు క్లాస్ మాట్లాడమని చెప్పారా? ఎవరు చెప్పారు క్లాస్ మాట్లాడమని? రెండు స్టూల్స్ తీసుకుని ఇక్కడ కూర్చొని వినండి, క్లాస్ వినండి. Okay, so minus IC2 by IC2 by IB1 into, okay, that I can write it as this is IB2 into IB2 by IB1 I can write. So whereas IB2 cancel, we'll get minus IC2 by IB1, that is our previous equation. Here minus IC2 divided by IB2 minus IC2 by IB2 into, in the place of IB2, the place of IB2 simply I can't write IC1. Simply I cannot write IC1. Whereas if you go for this voltage amplifier, voltage gain, so in the place voltage gain, so in the place of VB2, I wrote it as VC1. Why? Because both the resistors in parallel, so parallel connection, the voltage will be constant. So in the place of VB2, I can write VC1. But here, I cannot write IB2 is equal to IC1. Why? Because in the shunt connection, the current will be varied. Okay, so for that, what I can do is, this is a first stage amplifier. This is first stage amplifier. This is the second stage amplifier. In between, I have one. This is called RC1 is there. This is ZI. Sorry, that we call it ZI2. Okay, so simply I can write. This is Z01. This is ZI2. Z01 indicates the output of first stage. ZI2 is input of the second stage. Here this is IB2 current and here it is IC1 current. Okay, so so see that the directions of the current both are opposite. From this I can write it as using what we call Norton's theorem. So IB2 equal to minus IC1 because the current direction is opposite, and opposite resistance will Z01 by Z01 plus Zi2. So from this I can write in the place of IB2 I can substitute this term. So that is minus IC1 Z01 divided by Z01 plus Zi2. Okay, in the denominator IBT is there, no? So into IB1. So IB1 is there, IB1. So that is minus IC2 by IB2 into minus IC1 by IB1 into Z01 by Z01 plus Z8. So that is equal to, this is AI2 second stage into A1 first stage into Z01 by Z01 plus Z8. This is overall current gain. Okay. So here also we need to calculate what is AI2 and what is AA1. We need to calculate. Okay. So this is the current gain. Next, overall input impedance. Overall input impedance. Okay, so this already I told the overall input impedance Zi is nothing but input impedance of the first stage. First stage input impedance is nothing but overall input impedance. Okay. Similarly, overall output admittance or impedance is nothing but Y naught is equal to Y naught 2. Okay, or Z naught equal to Z naught. Okay, so you admittance or impedance. So Y naught means Y naught 2, Z naught means Z naught 2. So the last stage output impedance will becomes overall output admittance. Okay, so what we call the last stage output admittance impedance is nothing but overall output impedance. The first stage input impedance is nothing but overall input impedance. Okay, so these are the overall current gain, overall voltage gain, overall input impedance, overall admittance. So now we are going to calculate individual voltage gains to get the overall voltage gain. So if you know that AV1 and AV2, then you can have overall voltage gain. Similarly, if you have AI1 and AI2, you can have the overall current gain. Similarly, if you know that Zi1, you can have the overall input impedance. If you calculate Z02, you can have the overall output impedance. Okay, so these are the overall current gain, voltage gain, input impedance, and output impedance. Now let us look at how we can calculate this voltage gain, current gain, individual stages, input and output, individual stages. So for that, I'm going with H parameter analysis. So for your easy convenience, I will write H parameter equations for C amplifiers. H parameters equations, that is VB is equal to HIE IB plus HRE VC, IC equal to HFE IB plus HOE VC. So this is general for C amplifier. I am not writing it as a single stage or first stage or second stage. If it is first stage, in suffix we will add 1. So VB1 equal to HIE IB1 plus HRE VC1. IC1 equal to HFE IB1 plus HOE VC1, like that. Okay, so here we are not going to add suffix for the H parameter. So you see, you need not to write HIE1, HIE2, HFE1, HFE2. Why? Because both are similar, same type of C amplifiers. So both are C amplifiers. So H parameters of the first stage and the second stage will be same. The H parameters of first stage and second stage will be same. So that is for that reason you need not to separate by mentioning the suffix 1 and 2, that H parameters. You need not to mention that. Okay, so simply you can write HIE, HRE, HFE, HY for the first stage as well as the second stage. Okay. So on this H parameter model, the circuit is, we can draw this like this, HRE, and this is the circuit model. Okay, H parameter model. So this is 1 by HOE VC HFEIB, and this is HREVC. This is HIE. The current is IB. Okay, this is H parameter model. Okay, so single transistor. Now I will come to. Okay, so let us draw the H parameter model for the two-stage RC coupled amplifier. Let us draw the H parameter model for the two-stage RC coupled amplifier. Now let us go back and let's see the circuit of this. So see amplifier. So there are the two transistors are there. So two transistor means we have to draw the two H parameter models for each one each transistor. So each one for one transistor. So I will draw the H parameter model for two-stage RC coupled amplifier. Two-stage RC coupled amplifier is. So I will draw the simplified version. This is RS, HIE, HR into VC, HF into IB1. Write it as VC1, IB1. Why? Because the first stage. This is 1 by HOE. This is RC1, HIE, HRE, VC2. Okay, VC2. This is HFE, IB2, 1 by HOE, RC2, RL, RC2, RL. Okay, so look at this. So what I did is, okay, simply I just replaced an H parameter, the transistor place lo H parameter model better. Okay, now you can compare your previous circuit and here. Okay, so see this transistor. Okay, so here this is the transistor here, base, emitter, collector. This is base, this is collector, the emitter. Okay, and for the base terminal, so there are the two resistors are there, so R1 and R2, and the collector it is one resistor is there, and the emitter is anyway, and this all capacitor will be replaced by short circuit. So capacitor to the short circuit and the short circuit parallel to RE, it becomes 0. So emitter ki a resistors undam. So let us look at here. So this is the base terminal, collector terminal, emitter terminal. So emitter there is no resistance, and collect base kochesi there will be two resistors. Actually, that is one resistor and one resistor base to emitter. This is R1 and R2. But if you take the parallel combination of R1 parallel to R2 parallel to HIE, R1 parallel to R2 parallel to HIE, that is approximately equal to HI only. Okay, why? Because R1 R2 values will be high. You can neglect that R1 R2 resistor. So for that reason, so here I'm not taking this R1 R2. Okay, So similarly, so for a second stage also there will be two resistors called R3 and R4 like this. So R3 and R4. Here also R3 parallel to R4 parallel to HIE becomes approximately equal to HI only. Okay, so that is the reason here also I'm not taking R3, R4. Okay, so and output it has the first stage output has the output collector came on the RC1 resistance, and here also base collector emitter, and so for collector one more R2 resistor is there and RL resistance are there. So see the second stage. So this is the collector terminal. For collector terminal RC2 is there and RL is there. Okay, so for that I kept it is as it is, and this is your H parameter mode. Now let us calculate. Now let us calculate that individual current gain, voltage gain, input impedance, output impedance for what the second stage, last stage first. Last stage nunchi we'll come back to first stage. Okay, so second stage analysis. Second stage analysis. Second stage analysis. Okay, so second stage. Now let us look at, so from this you can write it as ZL2 is equal to RC2 parallel RL, ZL2 equal to RC2 parallel RL. So in the place of these 2 I can write it as ZL2. Okay, so equation IC2 equal to HFE IB2 plus HOE VC2. Okay, same equation I wrote it for the second stage. Okay, so same me H parameter C amplifier ఎలా ఉందో same derivation, only thing is the second stage కాబట్టి second suffix 2 అని పెట్టుకుంటే వెళ్ళాలి. So that is HFE IB2 plus HOE minus IC2 into ZL2. You can see the H parameter analysis for single stage. Okay, that same as it is, and IC2 plus IC2 ZL2 equal to HFE IB2. So whereas IC2 by IB2 equal to HFE by 1 plus HY into ZL2. So therefore AI2 equal to minus IC2 by IB2, that is equal to minus HFE by 1 plus HY into ZL2. Okay, so this analysis is same for the single stage C amplifier lo ఎట్లయితే చేశారో same. Okay, so what Varun ఏం రిపీట్ చేయాలి? Once again post it what I need to repeat. Varun, why I'm not getting your voice?
Sir, overall current gain.
Varun, what I have to repeat? Please post again. Overall current again. Okay. Okay. So this is the overall current again. So A equal to actually the load current by input current. So IL by B1. But the load current and the secondary stage collector current will be opposite. So I can take it as minus IC2 in the place of IL by B1. So that I can split into IC2 by IB2 into IB2 by IB1. So whereas IB2 IB2 cancel, you will get the previous equation. Okay. So now minus IC2 by IB2 is same. Now I have to I want to convert that. So IB2 is nothing but input of the second stage. The IB2 is the input of the second stage. So that IB2 we should convert in terms of the output of the first stage. And IC1 lo convert cheyali. Therefore you will get individual current gains. Okay. So to convert that input current of the second stage to the output of the first stage, I just wrote, I have taken this circuit. Okay, so this is the first stage. First stage నుంచి ఏమొస్తుంది? ఫస్ట్ స్టేజ్ లో ఒక లోడ్ రెసిస్టెన్స్ ఉంటుంది, నెక్స్ట్ సెకండ్ స్టేజ్ ఒక లోడ్ ఇన్పుట్ ఇంపెడెన్స్ ఉంటుంది, దట్ ఇన్పుట్ కరెంట్. సో దిస్ ఈజ్ IB2, this is IC2 current, and this is Z01 is the output resistance for the first stage. Zi2 is the input resistance of the second stage. Whereas the same circuit for the overall current gain, voltage gain is a circuit. Voltage gain is a circuit. But voltage gain and రెండు రెసిస్టర్ ప్యారలల్ ఉన్నప్పుడు voltage will be same. So మీకు VC1 అన్న VB2 అన్న రెండు సేమ్, ఎందుకంటే షంట్లో ఉన్నప్పుడు ప్యారలల్ voltage will be constant. But that is not the case with current gain. So for that I wrote the equation IB2 is equal to opposite supply. So both are opposite, no? So minus IC1 into Z01 by Z01 plus Zi1. So this IB2 I substitute in this equation. Okay, in the place of this IB2, I substitute that this minus IC1 into Z01 by Z01 plus Zi2, and then I rearrange the equation, I wrote it. Okay, so the only difference between the overall current gain and voltage gain ante same circuit untundi, but voltage gain ante resistors parallel kabatti voltage will be constant. Okay, the voltage will be constant in the parallel resistance, but current will not constant in the parallel resistance. Current will not be constant. So therefore this is overall current gain, and that's the reason we are getting some extra term, that is Z01 by Z01 plus Zi2. So this is already I told in the previous class also. Yesterday class, I mean day before yesterday, I think we discussed this overall current gain and overall voltage gain. Is it clear? Varun, is it clear?
Yes, sir.
Is it clear, Varun?
Yes, sir. Yes, sir. Yes, sir.
Okay. So now let us go to next one. So that is input impedance of the second stage. Okay, input impedance of the second stage is Zi2 is nothing but VB2 by IB2, where VB2 is HIE IB2 plus HRE VC2 by IB2. So you separate HIE, IB2 IB2 cancel, plus HRE VC2 is nothing but I can write minus IC2 ZL2 by IB2. So this HIE plus HRE, okay, HRE what HRE into AI2 into ZL2, same derivations. C amplifiers మీకు ఏదైతే వచ్చిందో same. Okay, you can go with that. Next voltage gain. Voltage gain. Okay, so AV1 AV2 equal to VC2 by VB2, whereas VC2 is minus IC2 into ZL2, VB2 is nothing but IB2 into Zi2. So in the place of this, you can write AI2 ZL2 by Zi2. This is AB2, overall voltage gain. Sorry, a second stage of the voltage gain of the second stage. Next, output admittance. Okay, so for this I can write IC is equal to H of E IB2 plus HYE VC2. Okay, we know that when you're calculating output admittance, input will be constant, that is VB2 equal to 0. So therefore we know that equation VB2 equal to HIE IB2 plus HRE VC2. So if it is 0, VC2, so from this HIE IB2 equal to minus HRE VC2, IB2 by VC2 equal to minus HRE by HI. This you can substitute. So if you write this equation again, why not 2 equal to, I can write IC2 by VC2 where IC2 equal to HFE IB2 plus HOE VC2 by VC2. You will separate, you will get HOE plus HFE into IB2 by VC2. Okay, so HOE plus HFE, in the place of this you can substitute this term, so minus HRE by HIE. So finally Y02 equal to HFE HRE by HI. Okay, so this is the second stage analysis. Second stage analysis. Okay, so now coming to the first stage analysis. First stage. Now we'll come back to first stage analysis. Okay, so now let us substitute. So ZL1 equal to here, first stage load is equal to, okay, RC1 parallel to ZI2. So why? Because if you see the circuit, so this is the RC1, which is parallel to till to this point already calculated input impedance. Till to this point, you calculate input impedance, that is ZI2. Already we calculated. So the parallel combination will become, so the RC1 parallel to ZI2 will become your ZL1. Okay, ZL1 is equal to RC1 parallel to ZI2. Okay, so the output impedance of the first stage will be parallel to the output resistance of the first stage parallel to the input impedance of the second stage. So that will becomes our load. ZL1 equal to RC1 parallel to ZI2. So repeat the same procedure. Only thing is the suffix 2 is there, no, wherever it is you replace with 1. Same procedure, then no, there is no change. Wherever 2 is there in the second stage analysis, you just replace with 1. Why? Because this is the first stage. So you can write AV1 is equal to A1 into ZL1 by ZI1. A1 equal to minus HFE by 1 plus HO into ZL1. ZI1 equal to HIE plus HOE A1 into ZL1. Y01 equal to HOE minus HFE HRE by HI. Same formulas, same procedures. Only thing is the second suffix 2 is replaced with 1. Okay, why? Because this is the first stage. So now we can calculate the overall voltage gain. What is the overall voltage gain? AV2 into AV1. So AV1 you calculated, AV2 you calculated. Okay, so that is AV equal to AV1 into AV2. Both you calculated. Okay, overall. Next, current again. Overall current again into A1 into AI2 into Z01 by Z01 plus ZI2. A1 you calculated, A2 you calculated. Substitute. ZI2 also you calculated. Okay, so substitute you will get it. ZI equal to, I told ZI1. First stage input impedance is nothing but overall. So ZI1 already what is that? HIE plus HOE A1 into ZL1. Next, Y0 or Z0 is nothing but 1 by Y02. 1 by Y02. So last stage 1 by HOE minus HFE HRE by HA. So these are the overall voltage gains. Voltage gain, current gain, input impedance, output impedance. Okay. So like this, so if we know the H parameter analysis of CE amplifiers, it is very easy. It is very easy to their design. Only thing is అక్కడ మీరు one time చేస్తుంటారు analysis, ఇక్కడ 2 times చేయాలంతే. Okay. This is what our overall voltage gain, overall current gain, overall voltage gain, input impedance and output impedance. Any okay, any queries in this? Any queries? Varun?
Sir.
Am I audible now?
Yes, sir, you are audible, sir.
Okay. Okay, so this is a two-stage RC coupled amplifier, that is a cascade. Okay, now coming to the cascade, so the second type of the multi-stage amplifier is, okay, cascade amplifier. Cascade amplifier. So in this, we'll do the analysis for cascade is I told um, you can give with the CECC or CECB also. CECC or CECB, both are cascade amplifiers only. Okay, so here I'm taking CECC. Okay, CE with the CC amplifier. CE with the CC amplifier. So I will draw the circuit. So here I'm solving CE with CC. Okay, after this we try with CE with CB. This is also cascade. So you try with CE with CB. So by taking this combination. Okay, this is C, C, C. Okay, so this is the circuit of CE. Okay, so CE with CC. So for this input is for the first CE amplifier, the first stage is a CE amplifier. This is the CE amplifier here. The input is base terminal. Output is taken across the collector. Emitter is connected to the ground. So now output is applied to the base of input, the second stage. So this is the base terminal. Okay, this is the collector terminal and emitter terminal. So see the second stage, and input is applied to the base, output is taken across the emitter. So see the V0 we are taking across the emitter we are taking. Okay, across emitter we are taking, and whereas the collector is connected to ground. Of course, it is connected to VCC, but AC analysis, when you are doing AC analysis, VCC also will be connected to the ground. Okay, so the second stage is the CC configuration, and the first stage is the CE configuration. Okay, CE amplifier with CC amplifier. Now, the first stage input is VB1, first stage is VB1, and the first stage output is VC1. First stage output is VC1, and second stage input is VB2 because input is the base terminal, and output is, I can write as VE2. VE2. So why? Because the second stage emitter output is the emitter terminal, so output is VE2. Okay. So input is VB1. First stage input is VB1. First stage VB1 is the input of first stage. VC1 is output of first stage. VB2 is the input of second stage. VE2 is the output of second stage. Okay, VE2 output of second stage. So these four, VB1, VC1, VB2, VE2, VE2. Okay. VE2, output of the second stage. Right. So let us write. So overall current gain, overall voltage gain, all those things. Okay, here. So that is overall voltage gain. Gain is AV equal to, what is the output voltage of the multi-stage amplifier? VE2 by VB1, VE2 by VB1, that is equal to, I can write VE2 by, I can write VB2 in terms of I multiply and divide with VB2 because the input of the second stage is VB2, multiply and divide. If both gets cancelled, we get the previous one. So that is VE2 divided by VB2 into, so VB2 I can write it as a VC1. VC1. Because you see, this is VB2 terminal. Okay, so in the VB2, in between VB2 and VC1, there are the two resistors, that is uh, that I already told in the previous derivation also. Okay, so this is VB2 second stage. Okay, this is the second stage, and this is VC1, this is the first stage. Okay, so this is Z01, Z2. So input of the second stage, output of the first stage. This is okay. So both the resistors are in parallel connection. Both the resistors in parallel connection. So here you are taking VC1 across the Z01. You are taking VB2 across the Z2. So both are in parallel means, so VC1 is directly is equal to VB2 because in the shunt connections voltage will be constant. So VC2 equal to VB2. So for that reason, in the place of VB2, I can substitute VC1. Therefore, I can write it as AV2 into AV1. So overall voltage gain is equal to AV2 into AV1. Okay. Similarly, the overall current gain is okay. AI is equal to IL by IB1. IL by IB1. This equal to, so IL is, I can write it as minus IE2 by IB1. IE2. So why? Because second stage output is emitter terminal. Second stage output is emitter terminal. So I can write as minus IE2 by IB1. Why? Because both the currents will be in opposite direction. So minus IE2 by, I can split this equation into like this. Okay, so IB2 multiply and divide with IB2. Okay, so now this IB2 I have to convert in terms of the output current of the first stage, so that I can get the individual current gains of the first stage and second stage separately. Okay, to calculate this IB2 in terms of output current of the first stage, again take the same form, same circuit diagram here. What I'm taking here. Okay, so this is Z01, this is Zi2. So this current is IB2, this current is IC1. Okay, so this is Z01, this is Zi2, right? So here IB2 is equal to, see the directions of the current, both are opposite. So minus IC1 into Z01 by Z01 plus Zi2. So using that as a Norton's theorem, so IB2 equal to minus IC2, IB2 equal minus IC1 into Z01 by Z01 plus Zi2. Okay, so this you can substitute, in this equation, minus IE2 by IB2 into IB2 is minus IC1 Z01 by Z01 plus Zi2, okay, into 1 by IB1. This is everything is IB2. So this rearrange the equation, IE2 by IB2 into minus IC1 by IB1 into Z01 divided by Z01 plus Zi2. Okay, so finally AI equal to, this is AI2 into AI1 into Z01 by Z01 plus Zi2. This is overall current gain. Okay, but this is not the case with overall voltage gain. Why? Because the resistor in parallel, so the voltage will be constant, but the current will be varied. So hence we are getting some extra term like this. Okay, next, the overall input impedance is I already told. So overall input is Zi equal to Zi1. First stage input impedance is nothing but overall input impedance. Overall output impedance is nothing but Z0 equal to Z02. The last stage output impedance is nothing but overall output impedance. Okay, so these are the overall current gain, voltage gain, input impedance, output impedance. Okay, so now we are going to calculate what is this in this. So individual, so we know that AB equal to AB2 into AB1. So what is AB2, what is AB1, what is AI2, AI1, and now we are going to calculate. Okay, and now we are going to calculate. So since it is the second stage is a CEC amplifier, okay, we'll start with the second stage amplifier, second stage analysis. Okay, so now let us redraw the H parameter model. H parameter model. H parameter model. Okay, so in this H parameter models, when you are doing a AC analysis, so there are some steps are there, like so what are the steps? So replace all capacitors with short circuit, okay, and connect all DC sources to ground. Replace all active devices by H parameter model. So there is some procedure is there. So what we discussed in the second module. So according to that module, so I'm just redrawing that this cascade amplifier with H parameter model. So like this. This is the first stage. This is RS. First stage is a emitter, common emitter, so HIE. This is HRE PC1. This is HFE IB1, 1 by HOE. This is RC1. This is second stage a common collector, no, HIC. This is HRC. Output is VE2. Okay, output is VE2. And this is HFC. Input is IB, so IB1, 1 by HOC. This is RE2. Okay, now let us go back to the draw the circuit. So since the second stage is a CC amplifier, second stage is CC amplifier, output is taken across the emitter. Output is taken across the emitter here. Okay, VE2 is the output. So output resistance in T, RE2 is the output resistance. Okay, output resistance is RE2. And second stage is CC amplifier. So we have taken CC configuration, CCH parameters. CCH parameters. So we drawn like this. Okay, but in between the first stage we know that so there will be two resistors, that is R1 and R2. But if you take R1 parallel to R2 parallel to HIE, that is approximately equal to HIE only. That will be approximately equal to HI only. Similarly, here also there are two resistors will be there. So R3 and R4. Here also R3 parallel to R4 parallel to HIC, which is approximately equal to HIC. Okay, so that is the reason I'm not taking so intermediate resistance here. Directly I took so only HIE and from first stage and the HIC in the second stage. Okay, so here I'm taking output resistance is R2. Sorry. Here, so output resistance is RE2. Suppose if you have the load resistance here, so if you have one load resistance like this RL, and you can connect RL also here. Here, no issue, you connect one bar RL also here. That is RL. Okay, so now let us do this analysis for the second stage first, then we'll go back to the first stage. So second stage analysis, second stage. Okay, so ZL2 is equal to RE2 parallel RL. So this is nothing but I took it as ZL2. Okay, so H parameter analysis of H parameter equations for CC configurations. So we know that we are familiar with the CE amplifier, H parameter equations and H parameter model and everything. Just for I will write for a CC configuration. So okay, so I will write it here. Okay, now let us write for CE for CC. CE is VB equal to VB1 equal to first stage kabatti VB1 equal to HIE IB1 plus HRE PC1. Next IC1 equal to HFE IB1 plus HOE PC1. So input is base, output is collector for the CC configuration. So input voltage equation, output current equation. Input voltage equation, output current equation. Now coming to the CC configuration, what is input voltage for CC? So input terminal is also base terminal for CC. So VB2 equal to HIC input current. What is input current? Base only. So IB1, IB2 plus HRC. This is output voltage. For what is the voltage? Output voltage for the collector, common collector is emitter. Output terminal is emitter. So VE2. Okay. So output terminal for common collector is emitter. Output terminal. So we took it as VE2 and output current. And output current and output terminal is emitter. No. So IE2 equal to HFC IB2 plus HOC VE2. So these are the equations for common emitter and common collector. Common emitter and common collector. Right. So this is what these two stages. Now let us come to the second stage, ZLT equal to RE2 parallel to RL. Now first let us calculate the current gain. Okay. So second CC no. So IE2 equal to HFC IB2 plus HOC VE2. Okay. So this is the equation. So from this IE2 equal to HFC IB2 plus HOC, I can write minus IE2 into ZL2. Minus IE2 into ZL. So output voltage is equal to output current into output resistance. But output current is nothing but IL into ZL2. but IL will be opposite to the IE emitter current. So I took it as minus IE2 into ZL2. So same HOC IE2 ZL2 equal to HFC IB2. So finally I can write IE2 by IB2 equal to HFC by 1 plus HOC into ZL2. See, the same derivations are looking like same. Okay, so if you practice one derivation, so easily you can do it for the remaining CC amplifiers and CB amplifiers also, but only the notations you have to change, like what is the input terminal and what is the output terminal, like that. Okay, so A equal to minus IE2 by IB2, that is equal minus HFC by 1 plus HOC into ZL2. This is current again. This is current again. Okay, next input impedance. Impedance is nothing but ZI2 equal to VB2 by IB2, input voltage by input current. So whereas VB2 for the common collector is, the formula is this. VB2 formula is this: HIC IB2 plus HRC VE2 by IB2. Okay, now separate, you will get separate the terms HIC plus HRC, whereas VE2 is nothing but minus IE2 into ZL2 by IB2, that is ZI2 equal to HIC plus HRC into AI2 into ZL2. Minus IE2 by IB2 is nothing but AI2. This is input impedance. Okay, next voltage gain. Voltage gain. So that is AV equal to VE2 by VB2. VE2 is nothing but minus IE2 into ZL2. VB2 is nothing but cross multiply this IB2 into ZI2. So in the place of minus IE2 by IB2, I can write AV equal to AI2 into ZL2 by ZI2. This is voltage gain. This is voltage gain. And now do it for the world output admittance. Do it for the output admittance next. Output Can anyone help me to solve this output admittance of CC configuration? Can anyone do help? Can anyone help? Output admittance, how to solve? C1. C1.
Yes, sir.
Tell me the definition of output admittance.
Sir, doing.
LE16. LE16. LE16 not there. C3 C3 it's a waste of time. Y not to equal to output current by output voltage, that is HFC IB2 plus HOC VE2 divided by VE2. That is, if we separate the term HOC plus HFC into IB2 by VE2. So to calculate this relation, we know that input voltage will be constant, that is VB2 equal to 0. So that VB2 equal to HIC IB1 plus HRC VE2. So 0 equal to HIC IB, this is IB2, no? IB2 plus HRC VE2. IB2 by VE2 equal to minus HRC by HIC. Now substitute the term in this. So you will get Y02 equal to HOC minus HFC HRC by HIC. Okay, so this is output admittance for the second stage. Now coming to the first stage, okay, so first stage is nothing but so ZL1 is nothing but RC1 parallel to ZI2, second stage input impedance parallel to the collector resistance. Okay, now the procedure is same anyway. First stage is a CE amplifier. No, you can calculate. First stage is CE amplifier ante meeku first indak cheppanu kada, first stage same, just copy paste. So CE amplifier is same. So you will get AI1 equal to minus HFE by 1 plus HOE into ZL1 వస్తుంది. ZI1 equal to HIE plus HRE A1 into ZL1. AV equal to A1 into ZL1 by ZI1 వస్తుంది. Y01 equal to HOE minus HFC HRC by HIC వస్తుంది. HIE. Okay, so these are the first stage. Same, first stage is C amplifier, already we calculated twice in the previous derivation. So first stage. Next overall will be, so overall ante meeku already calculate chesi cheppanu kada. Okay, so overall AV equal to AV1 into AV2, A equal to AN into A2 into Z01 by Z01 plus ZI2, ZI equal to ZI1 equal to HIE plus HRE A1 into ZL1, Z0 equal to Z02 equal to 1 by Y02, that is equal to 1 by HOE. అంటే second stage is a common collector కదా, HOC minus HFC HRC by HIC. These are the overall current gain, voltage gain, input impedance, output impedance. Okay, so CECB also cascode amplifier. CECB also cascode amplifier. This is also cascode. Okay, if the question asks cascode, so derive then do the analysis of cascode amplifier, and you can do it for CECC or CECB. Okay, sometimes they will specifically ask CECB or CECC. Okay, so now, I already discussed CECC. You do it for CECB. Do it for CECB. Okay, the last topic is Darlington pair amplifier. Very important topic, Darlington pair amplifier. Okay, so in this Darlington pair, so there is a very important point is why are this is a special type of connection. CC Darlington pair is nothing but CC with CC. Very important topic. So this Darlington pair amplifier or Darlington pair connection is used to improve the input impedance. Is used to improve the input impedance. Okay, so out of three configurations of CECBCC, common collector configuration has highest input impedance. Highest input impedance. As if you see that typical value, if you see that characteristics of CECBCC, the input impedance of the CC amplifier is very high. Typically, it is around 200 kilo ohm to 300 kilo ohm. Typically, it is 200 kilo ohm to 300 kilo ohm. Okay, so for that reason, suppose if you take single stage, if you take right, typically it is 200 to 300. Suppose if you take the single stage CC amplifier, what happens is single stage CC amplifier తీసుకుంటే ఏమొస్తుంది, for example, so CC amplifier, no, CC amplifier ante this is output. Okay, so this is the one. If we take the Ri dash is nothing but so R1 parallel to R2 parallel to, that is HIC. Okay, HIC or Ri, HIC or Ri. So if you take Ri, so what will be the value of Ri? What will be the value of Ri ante, so Ri is equal to formula మీద CC amplifier ఏమొస్తుంది, HIC plus HRC into A into ZL something ఎంతో వస్తుంది, ఇది ఫార్ములా. ఓకే, సో ఇఫ్ ZIC is, what is the value of ZIC? This is 1100 ohms. This is 1100 ohms. HRC value ఎంత? So typical values of HRC What is the typical value of HRC? Any idea? HRC value, typical value. Okay, very good. Is 1. It is 1. Okay. AI into, so AI is nothing but current gain of the this what we call the CEC amplifier. It is around 50. It's around 50, let us say. Okay, into, and now this is 50 into 1 into 50 into ZL. The load resistance is general. How much will take? Will take the 10 kilo ohm resistor. General will take the load. So now calculate 1100 plus, so 50 into 10, 500K. So that is a 501.1 kilo ohm resistor. So the input impedance of the CC amplifier. Input impedance of the CC amplifier, you are going to get 501.1 kilo ohm resistance. This is the highest input impedance. Now, what you are doing, you are substituting this in this one. So because of this R1, R2 biasing resistors, because of R1, R2 biasing resistors, so what will be the values of R1, R2? R1 ante meeku almost let us say 47K ఉంటుంది. R parallel, R2 ante 4.7K ఉంటుంది. I will write here. Ri dash equal to 47K parallel to 4.7K parallel to 501.1K. This is input impedance. What will be the result? In the parallel combination, whichever is the least, that will be the equivalent resistance. So if you do that if you do calculate, approximately equal to, will come around 47.4 kilo ohm resistor. Okay, but actually the input impedance of the common collector, it is offering almost approximately equal to 500 kilo ohm resistor, but overall input impedance is coming only 4.7 kilo. This is the disadvantage for the common collector configuration. So to improve this input impedance, we are going to the Darlington pair amplifier. Okay, so we are improving to the, and so sometimes they may ask for the 2 marks questions or 4 marks questions. So show that R1, R2 biasing resistors are because of, so show that so that because of that R1, R2 resistors, that input impedance of the Darlington common emitter amplifier is getting decreased. Okay, so they may ask like that the question sometimes. So how R1, R2 resistors are involved? So to reduce that input impedance of the common collector configuration. So like this, you have to take some equations like this, and you have to do some taking some random values, and you have to explain like this. Okay, sometimes they ask. So this is the problem with the common emitter amplifier. So to improve this input impedance, the 4.7K to again 500K. So to restore or to improve the input impedance, we are moving to these techniques. Actually, there are the 2 types of techniques. What we have, one is a bootstrap technique, and second one is a direct coupling or Darlington connection. Direct coupling or Darlington connection. Okay, so now we are going to with the second one, bootstrap, that we are not seeing here. So we are going to see the direct coupling. Okay, so that is since the what is importance of the Darlington pair amplifier intended to improve the input impedance, So that is the reason. So why we are going for the this Darlington pair amplifier. Now let me draw the circuit diagram of common collector with the common collector amplifier. This is VE2, this is RE2, this is RS. Okay, only simple connection. You see first stage, okay, see the first stage, input is base, output is emitter, collector is connected to the VCC, anyway it is connected to ground. So emitter first stage output is connected to the input of the second stage, this is the base. Okay, so emitter is directly connected to the base. This is the direct coupling or Darlington pair. So the pair of these we call it as the pair of the this pair will call it as Darlington pair. Okay, the pair will call it as Darlington pair amplifier. Okay, Darlington pair connection. So this is the circuit diagram for the CC with the CC. So first stage is CC and the second stage also CC. Okay, now let us do it. So let us draw the H parameter model for the Darlington pair amplifier. Okay, let us draw it for the Darlington pair amplifier. So let me draw it. Let me draw it here. అట్లా ఉంటాడు మరి ఏమో లేదు బయటకు వెళ్ళాడు. The first stage is both are CC amplifiers, no? So you can write HIC, HRC, VE1, HFC, IB1. This is 1 by HOC, HIC. Since both are CC amplifiers, right? Also HRC, VE2, HFC, IB2, 1 by HOC. This is RE2. Okay. So here you can observe one thing. Here there are no biasing resistors for the first stage and second stage. No R1, R2, R3, R4. Why? Because if you have that R1, R2 or R3, R4, it is causes you to decrease your input impedance. So for that reason, I am not taking R1, R2 resistors here. Okay, it may cause us to decrease your input impedance. For that reason, so directly, so simple, only two resistors, one RS and RL. So the remaining everything is in terms of, even there is no intermediate resistor between the first stage and second stage also. Okay, so here there is no resistors also. So the here generally we'll have RC1 resistor in between here. Okay, but in this case there is no resistor directly coupled. Okay, so for coming to the second stage of CC configuration, so anyway it is here ZL2 is nothing but RE2 only. ZL2 is nothing but RE2 only. So now coming to this what we have ZL2 equal to RE2. So the analysis part already we did for the CC configuration, no, for the cascode CC. CC now we have to do for it for the 2 times. Okay, so here I'm writing the equations directly, but you are not supposed to write this equation directly in the examination. If they ask in the Darlington pair amplifier connection, I mean the question, you have to derive all the derivation part. ఓకే, నేను ప్రీవియస్లో వచ్చేసి కొన్ని మీకు తెలిసింది కదా అని చెప్పేసి ఇక సపోజ్ ఇప్పుడు ఫస్ట్ స్టేజ్ ఉంది ఇక్కడ, సో ఇక్కడ సి యాంప్లిఫైర్ కదా అని డైరెక్ట్ రాశాను. యు ఆర్ నాట్ సపోజ్ టు రైట్ ద డైరెక్ట్ ఈక్వేషన్స్ ఇన్ ద ఎగ్జామినేషన్స్, యూ హ్యావ్ టు సాల్వ్ ఇట్. ఓకే, సో మీకు ఆల్రెడీ మీకు ప్రీవియస్లో ఉంది కదా అని చెప్పేసి నేను డైరెక్ట్ రాశాను. So everything you have to solve in the examinations. So second stage is CC amplifier and the first stage is also CC amplifier. I can write AIT equal to minus HFC by 1 plus HOC into ZL2. ZI2 equal to HIC plus HRC AI2 into ZL2. AV2 equal to AI2 into ZL2 by ZI2. Y02 equal to HOC minus HFC HRC by HIC. So this is the second stage. You solve it and you will get the same formulas. Okay, and the first stage is nothing but first stage is also CC amplifier. So again A1 equal to minus HFC by 1 plus HOC into ZL1, where ZL1 is what? ZL1 ఏంటి? ZI2. Okay, actually ZL1 అంటే ఏంటంటే ZL1 is nothing but RC1 parallel, so output resistance parallel to ZI2 ఉంటుంది. But here there is no output resistance. Directly connect చేసాం కదా ఇక్కడ, there is no output resistance. Here it is directly connected. Okay, it's directly connected. You can say that this is infinity resistance అని. It is open circuit కదా, so open it is infinity parallel to input impedance of the second stage, and you will get in your second stage input impedance only. So ZL1 is nothing but ZI2. Okay, so ZI1 equal to HIC plus HRC, okay, A1 into ZL1, AV1 equal to A1 into ZL1 by ZI1, Y01 equal to HOC minus HFC, HRC by HIC. Am I right? So this is the first stage. And now overall becomes AV equal to as usual AV1 into AV2, AV1 into AV1 into AV2 as usual. AI equal to here the important thing is AI1 into AI2 only. So here you are not going to get that what term is there, no, you will not get. Why? Because in this circuit there is no intermediate resistance. In this circuit there is no intermediate resistance. So first stage is directly coupled to the second stage. So because of there is no resistor in between these two stages, so you will not get this term. If we have that output resistance and input impedance of separately, of course in the circuit you will be having that input impedance. I mean input impedance of the second stage. Only ఒకటే resistance ఉంటుంది కదా. So ఒకటే resistance ఉందంటే but maybe both opposite directions you will get IBT equal to minus IC1. That's only the difference. You will not get this term. Why? Because there is no the resistance between the first stage and second stage. So next one is ZI equal to ZI1 equal to HIC plus HRC into A1 into ZL1. Now let's come to this is a very, very important point. Very, very important. A is equal to, okay, so before this I will discuss about this current again. Okay, so and here also not. Okay, so AV1 is nothing but AI1 into ZL1 by ZI1 into AI2 into ZL2 by ZI2. Am I right? So first stage and second stage AI1 ZL1 by ZI1 into AI2 into ZL2 by ZI1. So here you can cancel ZL1 ZI2. Why? Because both are same. ZL1 ZI2 both are same. You can cancel it. Okay. So and now AI1 by ZI1 into AI2 into ZL2. Is it clear? So from this you can write, A1 is equal to what? A1 is equal to 1 minute. Yes. So AV1 is equal to this one. Okay. Okay. So here I can do one thing. 1 minute. Okay. So we know that ZI1 equal to HIC plus HRC AI1 into ZL1. So HIC plus HRC is anyway 1. So typical value you can verify it. So this is the 1. So from this AI1 into ZL1 is equal to ZI1 minus HIC. Similarly, AI2 into ZL2 equal to ZI2 minus HIC. So these two substitute here. AV equal to AI into ZL1 and ZI1 minus HIC by ZI1 into ZI1 or ZI2 minus HIC by, okay, so separate 1 minus HIC by ZI1 into 1 minus HIC by ZI2. So compare, we know that ZI is far greater than HIC. So we know that just I shown the example, input impedance will get so 500 kilo ohm and this will be just 1.1 kilo. When the previous I shown that taking some calculations. So far greater than, so you can take up, you can neglect this and neglect this. So 1 into 1, 1. So the voltage gain of multi-stage amplifiers of CCCC configuration is 1. Okay. Now the current gain is equal to AI1 into AI2. So this is minus HFC by 1 plus HOC into ZL1 into minus HFC by 1 plus HOC into ZL2. Here also HOC is what we call the lowest 25 microamperes. Okay. So compared to HOC, ZL1 is far less than 1. So here also you can neglect this term, you can then neglect this term. So minus of minus plus into minus plus HFC into HFC. So you will get HFC square, A equal to HFC square. This is overall current again. Okay. Next, ZI equal to, very, very important, HIC plus HRC AI1 to ZL1. So that is HIC's, let us keep it. HRC is 1, A1 into ZL1. Okay. So HRC, HIC plus minus HFC by 1 plus HOC into ZL1 here into ZL1. Okay. We know that this is negligible amount. So HIC, in the place of minus HFC, I can write 1 plus HFE. So the equivalent HFC equal to minus of 1 plus HFE అనేది ఫార్ములా మీకు బేసిక్ ఫార్ములా ఉంటుంది ఒకటి HFC equal to minus of 1 plus HFC. So this is overall input impedance. Okay. So now remaining you can calculate, and Y naught is Z naught is Z naught 2 is equal 1 by Y naught 2. That is same term. Okay. So this is what. So what for you are doing all these things, this Darlington parent test to improve the input impedance. Now let us verify. So whether the input impedance is increased or not, let us verify. Okay. To verify this ZI, so ZIC we know that the value, HFE we know that value, and ZL1 we have to calculate. So ZL1 and ZL1 is equal to ZI2 equal to HIC plus HRC and anyway 1. So AI1 into that is ZL2, for example. So HIC is 1.1K plus AA is nothing but, for example, let us assume that 50. Okay. So ZL2 is nothing but, I'm taking just for example 2 kilo ohm resistor, for example, or actually we will take a 10K. The load resistance will take it as 10K resistor. Okay, I will take it 10K. So finally 501.1 kilo ohm. This is what ZL1. Now substitute in this and we'll get ZI equal to 1.1K again. So 1 plus HFE. So it becomes 1 plus 50 into 51 into 501.1K. Now we calculate, and so you will get, I think, in terms of 2.5 mega ohms. I think, for example, approximately we'll get this 2006 something. Will get like this. You calculate. (51 into 501.1). So we'll get 2.25.55 mega. 2.25 mega వస్తుంది. This is highest input impedance.